All right, my third trimester Algebra 2 B'ers. Unfortunately, I am at a funeral today, and I'm sorry I can't be with you, but yeah, we'll plan on seeing you Tuesday. Just so I can introduce myself to you. Let's see if I can make this happen. Here I am. Look at that. An infinite number of me's. So that's kind of my ear hole, and an infinite number of them. But anyways, that's kind of me. Hello. I'm Mr. Kleefish. We'll meet you Tuesday. So here we go. This is your first lesson. Normally I would introduce you to myself and the class and everything. We're doing things a little bit out of order. So yes, you have homework, but really it's not due until Wednesday because Tuesday is going to be the introduction to my class and myself day with rules and all that jazz. So yeah, so you got a little extra time, but I appreciate if you give your best effort. If there's time in class, just get it done, and don't drive the sub nuts. And here we go. So 5-1 day 1, nth roots, radicals, rational exponents. And hopefully, you know, this has been handed to you so you can follow along. So it says, consider the following expression, the square root of 49. Now, hopefully, you know that the answer to that is 7 or -7. Now, you don't know this necessarily, but this positive answer is called your principal root. Now, just think of Mr. Hosford. He's a very positive guy, so principal means positive. That's going to have some significance in Unit 5, so I'm just going to get you thinking about that right now. But that's not even my point. It says, what are the parts of the radical expression? So you've got this thing, square root of 49, and there's some missing pieces in here. Just like when you write the letter X in algebra, there's an invisible 1 there, and there's an invisible 1 there. You just don't take time to write it because it's just implied. Same thing with this. We would say this is the square root of 49. Now, there's an invisible 2 there. There's an invisible 1 there. You just don't write it. Now here's the names. That thing is called the radical, hence the title. This guy is called the index. This guy is called the radicand. You don't really need to know that, but that right there is called the power of the radicand. All right, so there's all the parts. And it says, what is the geometry connection when it asks you to find the real roots? Well, this problem is actually a geometry problem telling you that the area of this square, so all the sides are the same, hence square root is 49. And the problem's actually asking you, when you see the square root of 49, it's telling you, hey, you got a square with area 49. What is one of its sides? And you would say 7. So that's why it's important to know math. 7 and -7 work, but in the real roots and the real, so really I'm talking all over the place. You only want this principal root, it's 7. Now, if you put plus or minus 7 for this problem, you wouldn't get it wrong, because mathematically it's true, but geometrically, your only answer is 7, because you can't have a negative side to a square. Now, here's the twist. How do you solve? Solve means find all values for x. So this is different. Now what I teach in class is a bunch of little jingles, so hopefully you're ready for that. But here comes one. Bada boom, bada bing, do the right thing. So you get x is plus or minus 7. Now if I let you guys do it in your head, I guarantee you some of you would say, oh, x is 7. And you only got half, which is half off, which is not good. So it's weird because the square root of 49, really the only answer that they want is 7, but you can put plus or minus 7. But if the problem says find all the values and you only give half, that's going to be half off. So you need to include both. That's why the jingle works. Bada boom, bada bing, do the right thing. Isn't that beautiful? All right, let's keep going. What's the difference between example 1 and 2? I just explained it. Okay, perfect squares. A perfect square is any square with an area such that its sides are whole numbers. Make a list of all the perfect squares up to 144. So there's 1, there's 4, 9, 25, whoops, missed one, 16, 36, 49, 64, 81, 100, 121, and 144. Now this list keeps going. I just wanted you to take a good look at all those perfect square roots. So if we grabbed one, square root of 81, our answer would be 9. If the problem says find all solutions, that's a bada boom, bada bing, do the right thing situation. You got to have both. So I hopefully I'm making that point clear. So what is the answer to the square root of a negative 144? Well, this you were taught in first try that you take the I out, so it's really the square root of negative 1 times the square root of 144, and then you get I square root of 144 because the square root of negative 1 is I, so you'd get 12I. Well, that means that this is really not possible. So as far as a real number goes. So the book might say not possible during this unit, even though you're used to saying 12I. So be prepared for both situations. They want you to know right now that this is not possible. Think about that. In the world of geometry, could you have an area of a square be negative 144? No. Can we handle it mathematically? Yeah, but we got to introduce the letter I. All right, on to the next page. So that's a warm-up. So it says, take a look at the expression. Is it okay to write it as the square root of 7 squared? And the answer is yes, because 7 squared is 49. Now remember, it says, what is the index of this? Well, there's a hidden little 2 in there. And it says, how can you make this equal to the answer 49? Now that's kind of a crazy question, but here's the point I want to make. Do you remember me explaining here the parts of a radical expression? We got the power of the radicand, and we got the index. Now watch this. We are going to take that guy, that 2, which is the power, and we're going to divide it by the index. So they're both 2's, so I'm going to get out a fancy color and highlight that yellow and highlight that blue, so we know the power is blue and we know the index is yellow. So we would rewrite that, experimenting with it, with the power over the index. So we got the power over the index. So why am I using a highlighter? Well, these numbers aren't always going to match, so you got to know where to put each piece. The power always goes in the numerator. The index always goes in the denominator. So what's 2 over 2? 1. What's that? 7. Isn't that what we got for this anyways? So this is a different way of doing math. And you're like, well, why don't I just do it this way? Well, there's going to be problems coming where you need to know this. So here we go. It says, consider the following. Oh, we're up to cubic roots. That means your index is now a 3. So the cubic root of 8. How do you say it? Just said it. Cubic root of 8. What's it even asking for? Well, really, cubic root comes from geometry. Now this time it's telling you the volume is 8. Find the length of one side. In other words, remember the volume is length times width times height. How can this and this and this, so here's my length, here's my width, here's my height, how can these all be the same number and be 8? So they're looking for one side, and that would be 2, because 2 times 2 times 2 is 8, but they're only asking for one side, so my answer would be 2. So what's the geometry connection? I just gave it to you. So now let's make a list of a bunch of perfect cubic roots. Now this list is smaller. The cubic root of 1 is 1, cubic root of 8 is 2, cubic root of 27 is 3, cubic root of 64 is 4, cubic root of 125 is 5. Now this goes on forever. Be careful with this guy, because the cubic root of 64, you guys have seen the square root of 64 so many times that you might say this is 8, and it's not. It's 4, because 4 times 4 times 4 is 64. So keep an eye on that. Now, I said earlier that you can't have a square root of a negative, and we talked about that. Is it okay to have the cubic root of a negative? Now, we got to let go of our geometry connection, because you can't have negative sides. So we got to totally go math here and go, is there a number multiplied by itself 3 times that gives me a negative 8? Well, first of all, what's a negative times a negative times a negative? Well, but guess what? That's negative. So you can have a cubic root of a negative. So what am I going to put in here as a number? 2, 2, 2. So what's my answer to this? Negative 2. Because negative 2 times itself 3 times is negative 8. So what's the cubic root of a negative 27? Well, that'd be negative 3. And if you want to check it, negative 3, negative 3, negative 3, that's 9. 9 times negative 3 is negative 27. So that means this must be my correct answer. All right, let's keep going. How can you rewrite this? Well, remember, guys, I'm going to write it a little bit bigger. You can rewrite it like this. So earlier, right up here, I said the power goes in the numerator, index goes in the denominator. Following that rule, it's going to be 8 to the 1/3 power. So what I'm trying to teach you is 1/3 is a fraction way of saying cubic root. So these problems are the same. This is the cubic root of 8. So we would say, aha, that's 2, no matter how you look at it. This, or this. So, can you rewrite the cubic root of 64 as 8, the cubic root of 8 squared? Well, what is 8 squared? That's 64. So the answer must be yes. Now, why am I saying that? This is what your homework problems are going to look like. So you got to know what to do with it. You take the radicand, that's the number, the big number underneath the radical. You put the power in the top. You put the index in the bottom. And then all of a sudden we've got this problem. What is better to do first if you have the expression like 8 to the 2/3 power? Well, on this one, let's go 8. So this is, think of this as your math homework problem. And student number 1 says they're going to go 8 squared first, so they get 64. Is that okay to do? Well, let's check it. What's this? That is your index. Now, what's the cubic root of 64? Well, we said that. It's 4. Well, what if a different student does this first, and they go the cubic root of 8, and they go, all right, the cubic root of 8, what is that? It's 2. Then they square it. You get 4. Notice we get the same thing. Now, some of you are saying, well, okay, I don't care which way I go. You better care. This is way better, okay? Think of it this way. If I have something like, I'm just saying 125 to the, I don't know, I'm just making this up, like 5/3. Do you really want to go 125 to the 5th power? Huge number, and then take the cubic root? No, no, no. Take the cubic root of 125. I got a really small pencil, so my handwriting is going to be a little funny. Cubic root of 125 is 5, and then we could go 5 to the 5th, and we could figure that out pretty easily. So that's the point I'm trying to make. All right, we're cruising. So with that being said, here comes very similar homework looking problems. So what is this? We're going to take the square root, so we're thinking of that as the square root of 100 first with a little 2 in there, and then we calculate that first to be 10. And now we raise that to the 5th power, and that's just a 1 followed by 5 zeros. So that'd be 100,000. So let's try this one. Do you want to go 64 to the 4th? I don't think so. And remember, there's going to be calculator portions of this test and non-calculator portions. So you got to know how to do these without a calculator. So what's the cubic root of 64? Well, let's take a look at it. It's a 3. All right, abort. All right, I'm going to use a pen. This is dangerous, though. Cubic root of 64 is 4. Now we got to raise that to the 4th power. Well, that's 4 times 4 times 4 times 4. That's 16 times 16, which is 256. Okay. All right. Now, this says rewrite this radical form. That's what it is, because it's got a radical, in simplest exponential form. So our answer is only going to have exponents. We're just going to use that rule. We're going to go x, remember the power goes in the top, index goes in the bottom, 2/5. Y, 3/5. And then we're done. I'm going to hit pause a second. All right, so we're back. Homework-like problems. What are all the real cubic roots of 125? Well, that's just asking you to figure that out. And that's just 5. Would negative 5 work? No. Why? Negative times a negative times a negative would give me a negative 125, so that's a no. All right, what are the real 4th roots of 16? All right, well, we get the 4th root of 16. What number times itself 4 times is 16? Well, 2 times 2 is 4, times 2 is 8, times 2, guess what? That's 16. So one of my answers is 2. Now let's check out negative 2 times negative 2 times negative 2 times negative 2. Well, that's 4, and that's 4. So 4 times 4 is 16. So I can get plus or minus 2 for that. Okay, so now, what is the meaning of the exponent in the expression 16 to the 1/4? Well, we've talked about that. That's the 4th root of 16. We're going to do that first, and we already know that that's 2, and then that is just to the 1st power, so that's just 2. What is the meaning of the exponent in the expression 27 to the 2/3? Cubic root of 27, do that first. That would be 3, because 3 times 3 times 3 is 27. Then we square it, 9. Let's try these. Get a little more difficulty here. 5th, and by the way, in this first unit, they're going to give you nice, neat things to deal with, so you can relax on that. So the 5th root of 32, well, to multiply a number by itself 5 times and get 32, it's got to be a pretty small number, so we're going to take a shot at 2. Just take a look at it. 4, 8, 16, 32. So the 5th root of 32 is 2, but you're not done yet. You got to cube that, so that's 8. This one, cubic root of 27, maybe we can do this in our head. 3. 3 squared, 9. Once you get good at these, they're pretty lickety-split. All right, we're almost done, guys. So, crazy little looking problem. Don't be intimidated by it. It just wants to show you how you can apply this sort of thing to real-life situations. And I find this kind of fascinating. But there's a Fujita or Fujita, I want to say fajita, but it ain't. Scale rating F, that's what this is. So that's the rating. And, uh-oh, students are coming. I got to hit pause. Actually, I'm going to finish. W is the estimated wind speed, and you can see they just give you the wind speed right here, so it's really just a plug it in. Wind speed of 100. So it's the cubic root of 100 over 14.1 squared minus 2. Well, this is going to require that we understand our calculators a little bit. So let's turn this on. Nice drinking faucet there. So I'm going to go 100 divided by 14.1, and I'm going to square that. So I'm just going to round it, 7.09 squared, 50.27. I'm going to round that also. So I get the cubic root of 50.27 Don't forget the -2. Now, how are we going to do that with a calculator? Well, there's a couple ways. We can go to this little symbol right here. So I'm going to go second, this button. I'm going to do it different because I'm running out of time. So I'm going to show you guys something. There's a 1 here, so I'm going to go 50.27. Remember, we can put this over this, so I'm going to go to the 1/3 power. And here's how I'm going to do that. 50.27 raised to the 1 divided by 3 power, and I'm going to hit enter, 3.69. Now there's different ways to do that, but that's 3.69 minus 2, so 1.69, and that's kind of like a Richter scale. I don't know if you remember that, but there's Richter scale and Fujita scale. Anyways, your homework is right here. Notice there's a couple from your workbook, and if you need one, it's over in the corner by the American flag, and then of course your textbook. If you don't have your online textbook, you're going to have to go over in the corner and take pictures of the actual hardcover books over there. So, hey, I look forward to seeing you guys on Tuesday.